Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence, the quality of video as well as audio, is it perfect or not? If it is perfect, just write perfect over the live chat, so at least I'll get to know everything is perfect. Anyways, the agenda behind today's video, as you can see over the thumbnail, I need to discuss about the concept of state space analysis. Anyways, if you look back in the last class, I could not complete the problems based on the concept of the phase margin and gain margin. So I am going to take the 2 or 3 specific number of problems based on the concept of PM and GM and even few important concepts within the PM and GM, and then straight away I will be moving into the concept of state space analysis. Agreed? So again come back and put the heading as a gain margin and phase margin, which we were discussing in the last class. See, here I am taking one very important concept within the concept of gain margin as well as phase margin. For that, what I had to do, I have taken a type 1 system, and order of the system is 3. I have taken an OLTF whose type is 1 and the order of the system is nothing but the 3. So in future, once I will be taking the characteristic equation out of the OLTF, the 3 number of poles you will be having. See, what we wanted to do over here, I wanted to analyze the relative stability of the different systems. Relative stability, that means graphically now you would be able to visualize which system is more stable and which system is lesser stable with the help of phase margin and gain margin. In yesterday's class, whatever the calculation, whatever the conclusion we retrieved in terms of numeric values. Where the phase margin was higher, that was a higher system. Where the gain margin was higher, that was a higher stable system. But let me tell you each and everything on a graph, so such that you would have a better understanding. Yes. So what I am going to do, I am going to draw a polar graph. It's 0 degree line, minus 90 degree line, minus 180 degree line, and minus 270 degree line. Now I have taken a constant unity magnitude circle, sort of this. Yes, constant unity magnitude circle. Agreed? Now I have taken a type 1 order 3 system. May I know for the type 1 system the initial angle would be minus 90, and similarly what would be the final angle? If we have got the 3 number of poles itself, the final angle would be minus 270 degree. So I have got the 3 or 4 different systems for which the polar plot is going to be drawn over this polar graph paper. Let's take, this is what my first system is. Sort of this. It starts from minus infinity, taking the reference of minus 90, and at omega is equals to infinity, the magnitude becomes 0, and it takes the reference of minus 270 degree. Let's take, this is what my system number 1. Similarly, let me take the second system, and the polar plot for the second system is somewhere like, again it starts from minus 90 degree, taking the magnitude of infinity, gets terminated at omega is equals to infinity, taking an angle of minus 270 and the magnitude as 0. You can see by yourself. Now we have taken the third system. The third system is sort of this, and let's take last never the least the fourth system, which has its polar plot sort of this. So the greenish curve is the polar plot for the first system. Similarly, this pinkish curve is the polar plot for the second system. The yellowish curve is a polar plot for the third system, and this reddish curve is a polar plot for the fourth system. May I know among the 4 number of systems which are gonna be better stable system and which are gonna be a lower stable system, what would be their gain margin, what would be their phase margin, where the gain crossover frequency would lie and where the phase over cross frequency would lie. Let me focus over the S1. May I know how the gain crossover frequency is being defined? The gain crossover frequency is the frequency where the gain offered by the system is precisely unity in the scalar domain and similarly 0 in logarithmic domain. You can see very well the polar graph is drawn over the polar graph paper where the magnitude is calculated in the linear scale, and you can see very well if it is a constant unity magnitude circle. So the point at which the polar plot crosses through this unity circle, definitely the operating frequency has to be omega gc. So you can see very well this is nothing but the omega gc for the first system. This is nothing but the omega gc for the first system. And similarly, if we'll go ahead, the value of omega is keep increasing because it has started from omega is equals to 0. Omega is keep increasing, and after certain traveling in omegas, now you can see very well the system is attaining an angle of minus 180 degree. What does that mean of it? That means here the operating frequency must be equals to of omega pc. Omega pc, yes, must be omega pc, and that is happening with all of them. Here it becomes omega gc, here it becomes omega pc, and similarly if we take the reference of s of 2, here it would become omega gc for the system 2, I may write it omega gc2, and similarly here it would be omega pc for the second system, you may write omega pc2, omega pc2. And similarly for the third system also, you can see very well this is the point when the gain offered by the system is unity as it is crossing through a unity circle, and at the same time this is the frequency at which the gain or angle offered by the system is precisely minus 180 degree. So you can see very well this is an interesting case where at the same frequency the gain offered by the system is unity and the phase offered by the system is minus 180 degree. You can see very well this is the point where the gain of the OLTF is crossing a unity circle, and similarly the phase offered by the phase is crossing to minus 180. Yes, agreed. So here we have got a spatial condition where the omega gc and omega pc is very same. Omega gc and omega pc is very same. Agreed. Now if we take the fourth system, you can see very well as the value of omega is increasing from omega is equals to 0 onwards, slowly the curve is going towards the second quadrant, and you can see very well at very beginning it crossed minus 180 degree line. That means at least for the fourth system omega pc have occurred earlier. Now as the omega is keep increasing, the magnitude is keep decreasing, and you can see very well this is the point at which the gain offered by the system was precisely unity. Obviously here the operating frequency would be omega gc. Here operating frequency would be omega gc. Agreed. May I know what it is? Anyways, if I would be interested in finding the gain margin as well as phase margin, I would be calculating the gain margin in linear scale, and phase margin it remains only in degrees. Either you take the Bode's or either you take the Nyquist. There is no change as such. Tell me, for the system 1, how will we get the phase margin? First I would connect this with this. Agreed. And then I would take this angle, and always I take this angle clockwise direction, and hence the angle which was measured at omega is equals to of omega gc would always be negative. For the time being, let's take it is somewhere minus 110 degree, somewhere at minus 110 degree. Agreed. Similarly, if we talk about the second one, if we'll calculate the angle offered by the system, at omega is equals to of omega gc2. So what I would do, I would extend a line till this point, and now I would calculate the angle offered by the system. Just a minute, angle offered by the system. Now obviously it is more lagging. For the time being, let's take it's a minus 130 degree. Agreed. Nobody should have any doubt as such. Similarly, if we talk about the system number 3, may I know what would be the angle offered by the system at omega is equals to omega gc? Altogether you had to start from here and you had to come till minus 180 degree. Agreed. Minus 180 degree. And similarly, if we talk about the phase margin offered by the fourth system, definitely you had to calculate the angle offered by the system at omega is equals to omega gc. For that, what you had to do? You had to connect this point and you had to calculate the angle in clockwise direction. May I know how much angle it would be? It would start from here and all the way it will go till this. For For the time being, let's take this angle. Obviously, it would be minus in between minus 180 degree to minus 270 degree. You can take angle somewhere maybe minus 250 degree. Minus 250 degree. Yes. So if we calculate the phase margin of the first system, phase margin of the second system, phase margin of the third system, and phase margin of the fourth system. Let me focus over the phase margin of the first, second, third, and fourth system. Tell me, what would be the phase margin of the first system? How the phase margin is being calculated is nothing but the 180 degree plus of the angle offered by the system at omega is equals to of omega GC. You can see very well the first system, how much angle it was offered? It was offered minus 110 degree, 110 degree. So obviously simply it's gonna be plus 70 degree. Plus 70 degree. Agreed? If we talk about the PM2, how much it is? It's gonna be 180 degree plus of angle offered by the system at omega is equals to of omega GC. So we had to focus over the second system. You can see very well it is crossing at omega is equals to omega GC2, and we calculated the angle. The angle was somewhere minus 130 degree. Minus 130 degree. So here it's simply gonna be 50 degree. Simply gonna be 50 degree. Agreed? Nobody should have any doubt as such. Similarly, if we talk about the phase margin 3, what does that mean by the phase margin 3? It's 180 degree plus of angle offered by the system at omega is equals to of omega GC3. You can see very well the omega GC3 is at minus 180 degree. So all the way, if you will calculate the angle is going to be minus 180 degree. Here it becomes 0. Here it becomes 0. And similarly, if we talk about the phase margin for the last system or the fourth system, here it would be 180 degree plus of how much angle was offered by the system, all the way the angle was minus of 250 degree, minus of 250 degree. So here the angle is gonna be minus 70, minus 70, agreed? Anyways, as I was discussing in the last class, if we talk about the stable system, the value of phase margin has to be positive. If we talk about unstable system, the value of phase margin has to be negative. So you can see very well, the first system is a stable system. So may I know, when you would be having a stable system, you would be having a stable system only and only if the intersection between the polar plot and unity gain circle is at third quadrant. Yes. If it is at third quadrant, whatever the angle would be calculated in the clockwise direction, it would be in between 0 to minus 180 degree. And the factor which is coming in between 0 to minus 180 degree, definitely after getting added with the 180 degree would lead a positive value. You can see over here, you can see over here. And now if you will compare the first and second one, their intersection angle was bit higher in clockwise direction. Initially it was minus 110 degree, now it was changed to minus 130 degree, and the third system has the intersection angle exactly at minus 180 degree, and that is why it got down to 0. And if we talk about the fourth system, now the intersection between the polar plot and unity gain circle is at second quadrant. You can see very well the angle has been measured negative, and that is lesser than minus 180 degree. The outcome was minus 70 degree, minus 70 degree. Agreed? So you can see very well this was the bit idea about the phase margin. Bit idea about the phase margin. Till this point nobody should have any doubt as such. Agreed? Till this point nobody should have any doubt as such. Now. Let me focus over the gain margin. Let me focus over the gain margin. Yes, let me focus over the gain margin. Tell me what would be the gain margin? What would be the gain margin? What would be the gain margin? Let me do one thing. Some knocking sound is coming. Let me see that and try to get the gain margin. Try to get the gain margin. Yes, so till this point probably each and everything must be clear. So may I know which is more stable system? Definitely the first system is a more stable system in compare with the second, in compare with the third, and similarly in compare with the fourth. And you can see very well the fourth is gonna be a unstable system, unstable system. Now if we talk about the gain margin of the individual system, how will we get the gain margin? May I know how we get the gain margin? We calculate the magnitude offered by the OLTF at omega is equals to omega PC. So it's precisely known to me for the first system, gain offered by the system at omega is equals to omega PC. What does it mean by the omega PC? The frequency at which the phase offered by the system is minus 180 degree, or the given Nyquist or the polar plot is crossing through the minus 180 degree. So the gain is nothing but A. So simply you can see the gain margin is gonna be 1 upon A, 1 upon A. If we talk about the gain margin of the second system, gain margin of the third system, gain margin of the fourth system. May I know what would be the gain margin of the second system? You can see very well here, instead the A, now this factor is nothing but B. This factor is nothing but B. And where you can see very well the B is greater than A. So if you'll compare the gain margin between 1 and 2, precisely you can say the GM2 has a lesser gain margin in compare with the GM1. So definitely GM2 is more stable system in compare with the GM1. Agreed? Similarly, if we talk about the GM3, what is the GM3? You can see very well it was a unit circle, and at omega is equals to of omega PC, it is crossing through the same circle. What does that mean of it? That means the magnitude itself was 1. So one thing is quite sure, the gain margin offered by the system is precisely 1, And if we talk about the GM4, now the magnitude you had to take somewhere here, which is C, and you can see the value is even lesser than 1. You can see very well 1 upon A is greater than 1, 1 upon B is greater than 1. So the GM1 and GM2, the value was greater than 1. What does that mean of it? In future, you can pump the amount of gain, still the system would remain stable. Like, if you wants to keep this system stable, what you will do? First you will draw its Nyquist plot. Nyquist plot would be sort of this. Still minus 1 plus J0 has not been circled. Yes. Now if you'll expand it, how the expansion is possible? Just by increasing the value of K. If you are expanding it, so how much gain you can offer such that the system would still be a stable system? How much gain you can offer? That is nothing but 1 upon A. Once the A gets multiplied with the 1 upon A, what would happen? It would just be crossing with minus 1 plus J. And now if the gain has been further increased, definitely minus 1 plus J0 would encircle and the system would become an unstable system. Agreed what I am saying? Do you have any doubt now? So at least you can say one thing. As far as the gain margin is concerned, for the first system, the gain margin is greater than 1. For the second system, the gain margin is also greater than 1, but definitely lesser than the first system. And if we talk about the GM3, the gain margin is precisely 1. That means you cannot offer the gain more than 1. If you are offering the gain exactly equals to of 1, that means you have not been left out with additional gain put together. Now you have reached to a marginal stable system, and now you can see very well here the value itself is lesser than 1. That means you have not been left out with any gain. The system is a precisely unstable system, So may I know, if we talk about the system 1, it is going to be a stable system. Similarly, if we talk about the S2, it is going to be a stable system again. If we talk about the S3, S4, here it is going to be a marginally stable system, and here it is going to be a unstable system. Agreed what I am saying? May I know among S1 and S2 which is going to be the higher stable system? Here the stability is higher, and here the stability is lower. Till this point, nobody should have any doubt as such. If anybody is having any sort of doubt, you can post over the live chat. So at least I'll try to address those problems. So that is what I am saying. The phase margin and gain margin talks about the relative stability of the system. Which system is more stable? Like, you can compare S1 and S2 as they had the better values of PM and GM, they were the stable system, higher stable system. And similarly, if we talk about the S3, even a bit more gain has been provided to the system. Obviously, the system would become an unstable system. It is a marginally stable system. If we talk about the S4, it becomes an unstable system. If it is clear, just write clear somewhere. So I will get to know I will get to know that each and everything is clear to all of us. I will get to know each of us are clear or not. Now, one thing was asked in last class, sir, why the face margin we used to add the 180 degree with the angle offered by the system gj omega hj omega at omega is equals to of omega gc. Omega gc, see, basically we are interested in this angle. See, this is minus 110. Now I am interested in this angle, this angle. If in future, if the phase lag has been provided with the remaining angle, already it was 110 degree, if more 70 angle has been provided, keep in mind the system would become, or system would go into the verge of instability. That is why what we do, I used to calculate the angle offered by the system in clockwise direction, which used to be minus in nature, and now how much angle has been left out, how will you calculate? Obviously this complete angle is known to me, this complete angle is nothing but 180 degree, so definitely the remaining angle, how will you get to know? Just add 180 degree out of the angle offered by the system, OLTF. So now nobody should have any doubt as such, from where the formula of the phase margin is equals to of 180 degree plus of gj omega hj omega at omega is equals to omega gc have been calculated or come out. Not only that, even sometime one more doubt comes in the mind, sir, in case of phase margin, why we take the reference of omega gc, my dear friends? See, omega gc, that means the operating frequency where the gain offered by the OLTF is unity. I wanted to encircle this minus 1 plus j0, so I should have a clear cut idea. Once I would be tilting this structure, this would come somewhere here. After taking some lag, it would come here. After taking lag, it would come somewhere here. And similarly, after taking the lag of 70 degree, it would come over here. And once I would be taking the angle or the lag more than 70 degree, the system would become an unstable system. That is why we used to calculate the angle offered by the system precisely at omega is equals to omega gc, because in future I need to encircle minus 1 plus j0. What does it mean of it? That means the radial distance from the origin is minus 1. That is why I have taken the reference of a unity circle. In future I would be rotating. So what would be happening? This greenish curve, no, in future would become sort of this. In future would be sort of this, and it would be keep changing its location, but still I used to take the reference of this. So Devraj madam had this doubt, sir, why we take the reference of 180 degree plus of an angle gj omega hj omega, that is also known why 180 degrees got added. And similarly, now many of us would have the clear cut idea why we take the reference of omega is equals to omega gc while calculating the PM. Now the second thing comes in your mind, while calculating the GM, why we take the reference of phase crossover frequency. See, in future you can see very well this system is a stable system. In future, if you wanted to calculate its gain margin, what you had to do? You cannot introduce phase into the system, you just had to pump the gain within the system. And once you will start pumping the gain within the system, what will happen? It would start bulging. So how much gain you can offer? For that, what you had to do? Now you are not introducing any phase shift, only and only gain has got changed. And if the gain is changing, it would be keep bulging. So you had to know at least this point what was the radial distance from the origin. Let's take if the radial distance is a, so 1 upon a gain you can provide more, such that a into 1 upon a would become minus 1. It is crossing through minus 1, and now if you would be providing gain greater than 1 upon a, what would happen? Now the minus 1 plus j0 would start encircling, and as the minus 1 plus j0 is started circling, definitely it would become an unstable system. So may I know, I need to take the reference of what? In future I am talking about the margin in gain, but I need to take, or I need to calculate this magnitude. This magnitude, how will you calculate? This is the magnitude offered by the OLTF when the phase offered by the system was minus 180 degree. That means the gain has to be calculated taking the reference of omega is equals to of omega PC. Omega is equals to of omega PC. Yes? If it is clear, just write clear somewhere, so at least I'll get to know each and everything is well known to all of us. Yes, so this was more or less the concept of the gain margin and phase margin. Still few more number of doubts I have got it over the Telegram group. Probably if the time permits, I would take those problem also. Let me go back to the few number of problems. Yes. what has been given in this problem. First, let me read where this problem have appeared. This problem have appeared in GATE Electrical year of 2011. The problem was framed by IIT Madras. Let's see what the problem states. And now, I expect you guys would be able to give the proper response for this given problem. The frequency response of a linear system Gj omega. Keep in mind, whenever they write Gj omega, basically they are referring Hj omega as a 1. Basically, it's a type of UFB system, is provided in the tabular form. Initially, at the first, probably the second problem which I have taken in the yesterday's class was based on the concept of the Nicholas chart, where we had a relationship between the gain as well as the phase offered by the system. Now, sir, anyways, I'll see that. Now, till this point, nobody should have any doubt as such. But now here the mathematically each and individual datas are being given. I need to get the gain margin as well as the phase margin for the given system. May I know how the gain margin is being calculated? First, for calculation of the gain margin, I take reference of omega PC. What does that mean by the omega PC? The frequency at which the angle offered by the system precisely becomes minus 180 degree. So you can see very well the gain offered by the system at omega is equals to of omega PC at omega is equals to omega PC. The angle offered by the system Gj omega is minus 180 degree, and at omega is equals to omega PC, the magnitude was given by the system, which is nothing but mod of Gj omega at omega is equals to of omega PC. Yes, in future would be used for the calculation of gain margin. Not only that, even you had to calculate the phase margin. For the phase margin, what you had to do, you had to go the search of the frequency at which the gain offered by the system becomes 1 in linear scale. You can see very well here it has been clearly written mod of Gj omega. The logarithmic scale has not been applied. So you can see very well, obviously this is the point where the omega reaches to the omega Gc, and here the gain offered by the Gj omega is precisely 1.0. So you can see very well, this is nothing but the angle offered by the Gj omega, Hj omega is equals to of minus 150 degree at omega is equals to of omega Gc. Agree? Till this point, nobody should have any doubt as such. And as I have been focusing over the phase margin and gain margin, obviously I would be able to calculate the phase margin and gain margin. How the phase margin was calculated? Now nobody should have any doubt as such what was the formula which we have been using probably in yesterday's class as well as in today's class, because each of the formulas have got their own basis. Even you by heart it, either you understand it, just use the same formula. What it is, it's a phase margin is equals to 180 degree plus of angle offered by the system at omega is equals to of omega Gc. How much it is? It is minus of 150 degree. You can see very well. It is nothing but plus 30 degree. Gain margin. How the gain margin is being defined? The gain margin is nothing but 1 upon the gain offered by the system. Here it is UFB system, so simply I would be writing mod of Gj omega at omega is equals to of omega PC. Although omega PC is not known to me, but the magnitude of Gj omega at omega PC is known to me, which is nothing but the 0.5. So 1 upon 0.5 is going to be 2. But keep in mind, some of the times they used to ask the value of gain margin in terms of dB, and sometimes they used to ask in terms of the linear scale. So here it is precisely given over the options. They have been asking the values in dBs. So what I would be doing, I would be just taking 20 log base of 10 of 2. 20 log base 10 of 2. Agreed? So may I know what is the best most answer we are getting? Tell me. So let me take the calculator. What's the best most answer we are getting? So here it becomes 20 log obviously base of 10 of 2 of 2. So here comes 6.02. 6.02. So the best most answer, the 6 dB approximately with a 30 degree. Obviously A is gonna be the answer. A is gonna be the answer. Agreed? Till this point nobody should have any doubt as such. Yes? Let me go ahead with the next problem if the time permits. Obviously I am going to take the next problem also, and then yes, the same concept which I was revealing just before taking the last problem, the same problem or the same concept has been used in the ESE examination paper of electronics, year of 1999. So obviously they have taken a type 1 system, that is why the initial angle is minus 90 degree, and similarly the difference between the number of zeros minus of number of poles are minus 3, that is why the final angle is minus 270 degree, which I was just discussing about, So let me tell you, or tell me, what would be the gain margin as well as phase margin? What would be the gain margin as well as phase margin? I want to know from each one of you. Tell me. Each one of you. For the better understanding, do one thing. Just a minute. Here this angle is being given, which is 30 degree. Tell me, what would be the phase margin and what would be the gain margin? Phase margin and gain margin. What would be the phase margin and what would be the gain margin? If you have the little bit idea which I was discussing just maybe 5 to 10 minutes back, probably you would be able to crack this problem out. What would be the value of phase margin and gain margin? The value of phase margin, where it is being calculated, is 180 plus of angle offered by the system at omega is equals to of omega GC. You can see very well it is a unity circle. That means this is the operating frequency of omega GC, and if we'll talk about the angle offered by the system at omega is equals to omega GC, from the negative real axis the angle was given as 30 degree, so obviously this angle would be simply minus 90 minus of 30, this would be minus of 120 degree. So the phase margin is nothing but 180 degree. The angle offered by the system Gj omega Hj omega at omega is equals to of omega Gc, which is nothing but minus 120 degree. So 180 gets subtracted with the 120, simply would become 60 degree. Till this point nobody should have any doubt as such. And similarly, if we talk about the magnitude, you can see very well many of us would have doubt. Many of us would keep the value as negative. No, my dear friends, I need to get the magnitude. What does that mean by the magnitude? Do you have any idea about it? What does that mean by the magnitude? I need to get the absolute value of the function at omega is equals to of omega PC. What does that mean by the omega PC? The frequency at which the phase offered by the system is precisely minus 180 degree, or the point at which it crosses through minus 180 degree. So here it is minus 0.75. It is the point towards the negative real axis, and that is why it has been taken as minus 0.75. But in future, how the gain margin is being calculated? It's 1 divided by the gain offered by the system, maybe Gj omega Hj omega at omega is equals to of omega PC. And if we'll talk about the magnitude, it would be simply 0.75. So you'll take 1 divided by 0.75. So the best most answer is gonna be D. Anyways, the D may not be visible. It's the 60 degree, and 1 divided by of 0.7.5. Yes, 0.75. Yes. Till this point, each and everything must be clear to all of us. Probably this was the last problem of the day, but still few number of doubts were asked over the Telegram group. So let me take those problems also. Let me take the problem which have come into the recent year of GATE examination. This problem have come in GATE year of 2019. You had to get the exact answer for this given problem. Yes. Probably this problem have come in GATE 2020. What the problem states? Find the phase margin of the system in degrees. I need to get, this problem have come in GATE year of 2020. I need to get the phase margin in degrees. Phase margin in degrees. Agreed? And here if we'll talk about the structure of the OLTF, GSHS has been clearly given, which is equals to of 2 times of S plus 1 divided by of S square. I need to get the value of phase margin for this given problem. Anyways, it was a NAT type of problem. So the person who have asked this problem on the Telegram definitely should watch this video carefully. I need to get the phase margin for this given problem. Tell me, what would be the phase margin for this given problem? Anyways, as I was discussing in the last class, whenever you come across any OLTF and you had to get the value of gain margin or phase margin, first try to draw its polar plot, because the polar plot is going to unfold so many unknown concepts. Agreed? May I know what would be the starting angle? The starting angle would be minus 180 degree. What would be the final angle? Finally, S plus 1 would also introduce plus 90 degree at omega tends to infinity. That means it would start from omega is equals to of 0 plus, taking the reference of minus 180 degree, and it would land up at minus 90 degree. Obviously here becomes infinity plus, and here also the infinity minus would come. Agreed? Till this point nobody should have any doubt as such. Now what we are going to do now, let me complete this out. So here comes 0 plus. So if we had to complete it, obviously if it is a type 2 system, the 0 minus and 0 plus would not be placed at the same point. There would be a phase difference of 2 times of the type of the system, which is nothing but the type of the system is nothing but 2. So the 2 is getting multiplied with the 180. There would be a phase shift of 360 degree between 0 minus and 0 plus. So obviously the complete polar plot would be sort of this. Agreed? Would be sort of this. So here goes Yes. Good evening, sir. Thank you. Thanks a lot. Sir. The Umesh Dande sir is there, the king of the control system. I am very blessed that he has given the chance to teach at least control system to you guys, and definitely you guys are going to enjoy the complete course structure which would be taken by the Dande sir, the marathon, the super marathon in tomorrow's class. So I would request to each one of you, if you really wants to know the actual crux of the control system, do not forget to attend the tomorrow's marathon, which would be taken by our great Dande sir. Thanks a lot, sir. Is that part clear? So now we had to discuss about the phase margin of this given system. Agreed? Now I would like to ask one thing. This phase margin, whether it will have the concept of the phase margin or the phase margin is gonna be infinite. I would like to ask from each one of you. Whether this problem would have the concept of the phase margin or not. I won't comment over the live chat. What does it mean by the phase margin? That means how much lag in the system I can introduce such that the system reaches to the verge of instability. What does it mean of it? That means if I would start giving lag into this system, agreed what I am saying? If I started giving the lag to the system, the minus 1 plus J0, would it get encircled or not? If minus 1 plus J0 is getting encircled after giving certain phase, like how much lag we can provide to the system, that is nothing but the margin in phase. Agreed what I am saying? So tell me, after giving certain tilt, can I go into the situation where the minus 1 plus J0 is getting encircled? So far it is not encircled. What I am saying, so far it is not encircled. How would we know whether it's encircled or not? Definitely I would be taking one ray outside and you would be seeing neither the upside nor the downside is getting encircled. Tell me, will we have a finite value of PM or not? Yes, we will have. See, if we'll start giving a certain lag, what would happen? The complete Nyquist plot, this curve would cross like this and this would be encircled. Now I would like to ask about the gain margin. What would be the gain margin in this given system? Leave about the phase margin. I know many of us would be able to give the value of phase margin after giving certain number of calculations, because we have by hearted each and every formulas. But that is why I used to say you need not to by heart any of the formula. You had to just go with the concept. Tell me, what would be the gain margin? No, leave about the phase margin and all. First discuss about the phase margin. This problem have come in GATE year of 2020. First discuss about the gain margin. What would be the value of gain margin? How much gain we can provide to the system maximum such that in future the system reaches to the verge of instability. That means minus 1 plus J0 would start getting encircled. Tell me what would be the gain margin. I want the value of gain margin. The gain margin is going to be infinity. Why? In future, rather giving the phase change, if you are keep pumping the gain within the system, what would happen? Rather starting from here, it would start getting bulged like this. Like this. It would be even bigger. It would be even bigger, but you can see very well the minus 1 plus J0 is never getting encircled. Although they have asked to calculate the value of phase margin, but still this is a well designed problem in which they may trap you guys to ask the value of gain margin. The gain margin is going to be infinity. Gain margin is going to be infinite. Definitely few of the answers have started coming. Few of the answers have started coming. Now let me focus over the phase margin. The phase margin is a finite in nature. How will you get to know? The standard procedures we have to follow. First focus over the gain crossover frequency, the frequency at which the gain offered by the OLTF is unity in linear scale becomes 0 in logarithmic scale. So what we would do? We would take the magnitude of this OLTF. So here it becomes mod of 2, change it in frequency domain, which is j omega plus of 1, and here it is minus of omega square. Yes, the frequency at which the gain offered by the system is precisely 1. That operating frequency is nothing but omega GC, gain crossover frequency. Yes. So may I know how much gain crossover frequency we have got it? So let me take the magnitude, and whenever we take the magnitude of any complex function you could have studied in the mathematics, you can take their magnitude separately towards the numerator and towards denominator. That would not make any effect. So here it becomes mod of 2 j omega plus 1 divided by of mod of minus of omega square. That is the basic concept of the complex variable which we have studied as a part of mathematics. And now instead the omega, definitely I had to feed omega is equals to omega GC. If I take the mod of the numerator, even at numerator also the same fundamental would be true. If the components are in terms of multiplication, their magnitude can be calculated separately. End of the day, it would not have any effect over the complete magnitude which we were calculating. Many of us used to have doubt over this point. They would have doubts, sir, should I calculate completely or should I take this complete magnitude together after taking the real part and imaginary part inside the determinant itself? No, not required. You can use the basic property. You can calculate the magnitude of this separately, and this separately. Still it would be the magnitude of 2 within the bracket j omega plus 1 divided by of minus of omega square. Yes. Anyways, let me do that so that the mod of 2 is simply going to be 2. And similarly, mod of j omega plus of 1, you can see very well the imaginary part of this complex number is nothing but omega. So we will take a square of it plus of 1, and at denominator you would be having omega square is equals to 1. Omega square is equals to 1. Is equals to 1. Anyways, I want the input from each one of you. After shifting the values, definitely you would get the value of omega. How? The 2 is getting multiplied with the omega square plus of 1. Omega square goes towards right hand side, simply would become omega square. Now definitely it is not a perfect quadratic equation. So what I would do, I would take the square both of the side. If I take square both of the side, the 2 becomes 4. The root over goes up. It's simply omega square plus 1, and here it becomes omega to the power of 4. Omega to the power of 4. And once we start multiplying them together, it's gonna be 4 times of omega square minus of omega to the power of 4 minus of 4 is equals to 0, or you can write this as omega to the power of 4 minus of 4 omega square plus of 4 is equals to 0, is equals to 0. Anyways, we have come across this situation many of the times. What used to be the alternative method, omega square would be kept as x. So in future now it becomes a quadratic equation, x square minus of 4 of omega plus of 4 is equals to 0. Here it is x, no? Need not to have confusion. Yes, here it is x. And now you can see very well, it is x minus 2 to the power of 2. Yes, that means the value of x is 2. The value of x is 2, 2. You can choose either of them. And end of the day, you are interested in finding the value of omega. So definitely the omega is equals to of root over x. So here comes the root over 2, and the value of root over 2 is nothing but 1.414. Agreed. Till this point, nobody should have any doubt as such. Omega GC 2.19. May I know, is that all of the calculation is correct or something mistake we have done it? Let me watch it again. So here it becomes 2, that is fine. Omega square divided by omega square, that is also okay. Omega square, the 4, probably each and everything is perfect. 4 of omega square, yes, plus of 4 it is, no? Plus of 4 it is. Yes. Anyways, get the value of omega GC. I would like to get the value of omega GC from each one of you. Each one of you. Yes. So from here, we would be getting the value of omega GC. So whatever the value have been posted, I am just using the same value. So omega GC is equals to of 2.19. Now what we had to calculate? We had to calculate the value of phase margin. What does that mean by the phase margin, which we have seen earlier? The maximum phase which can be introduced within the system in terms of lag, such that the system reaches to the verge of the stability. As we have derived its formula, what was the formula? The formula was 180 degree plus of angle offered by the system at omega is equals to of omega GC. So the angle offered by the system, because of s plus 1, there would be angle of tan inverse of omega plus, and similarly because of s square, there would be an angle of minus 180 degree. So this and this goes off. You have to feed just omega is equals to omega GC. You will get the answer. You will get the answer. Agreed? You will get the answer. So this is what the value of, this is what the value of phase margin was. Till this point, nobody should have any doubt as such. If still you guys are having any sort of doubt, you keep posting over the Telegram group. So either I would be replying over the Telegram group itself, or otherwise I would be taking that problem over the control system, So may I know, before going to jump into the next topic called state space analysis, I would like to ask from each one of you, till this point, the concept of the gain margin and phase margin, is it clear or not? If it is clear, just write clear, and then we'll move ahead with the next and very, very important topic, very conceptual topic, very interesting topic, and the topic would be state space analysis. Tell me, if it is clear, just write clear somewhere. And we'll move with the next important topic of the control system, and that is nothing but state space analysis. Clear, no? That's fine. So let me jump straight away into the next and very important topic, and that's nothing but the state space analysis. Anyways, before going into the detailed analysis of the state space analysis, let me brief about the state space analysis, and let me discuss few of the important point inside the state space analysis. So all of us had to mark few of the important points within the state space analysis. The first important point. The state space analysis, I would be calling it SSA in future, comes under the modern control system. Anyways, all of the tools within the control system which uses the transfer function as the input, they comes under the classical control system, like Routh-Hurwitz. May I know what was the input to the Routh-Hurwitz? Which was 1 plus GSHS. What was the GSHS? Which was a OLTF. Keep aside OL, it was a transfer function. Similarly, if you talk about the root locus, again the input was a transfer function. If you talk about the Bode, the input was a transfer function. If you talk about the polar Nyquist, the input was a transfer function. Keep in mind, whenever we deal with a certain problem where the input or the behavior of the system was given in terms of transfer function, those all concept or the all domain of studies are kept under the classical control system. And that means whatever we have studied so far, where the input or the system behavior was presented by its transfer function, comes under the classical control system. Yes. Classical control system. That means the analysis of the given system, or the approach towards analysis of the given system would be completely different in case of state space analysis. And here the classical control system, where we deal with the transfer function. We deal with the transfer function. Till this point, nobody should have any doubt as such. Agreed? Let me go back. Yes. Now let me briefly compare the transfer function approach and the state space analysis approach, and we'll try to understand which are the different points where we'll find the state space model or the state space analysis is much advantageous in compare with the transfer function. So let me list down the points at which the state space model would be much beneficial in compare with the transfer function model. The first important point. See, the basic definition of the transfer function was the output in Laplace domain divided by the input in Laplace domain, keeping all of the initial conditions aside. What does it mean of it? That means the transfer function has an inherent error that it cannot account the initial conditions. That means in future, if you have energy storing element within your circuit, those part cannot be considered in your analysis at all. That means the initial voltage across the capacitance has to be taken as 0. Sir, will you tell conical? Definitely, I would be coming in that also. Yes. So what I wanted to communicate. So whenever you come across the transfer function approach, by default the initial conditions has been left out, and definitely the error would be a major issue in that case. That's the first thing. As far as the state space model or SSA is concerned, even you can accept or you can consider the initial conditions also. That means definitely the analysis with the help of SSA would be more accurate in compare with the transfer function. So the first important point, SSA can include initial conditions in terms of its state variables. That we'll see. So one of the best thing about the state space model, obviously we are comparing with the transfer function model. That's the first thing. The second important thing, if you'll recall how the transfer function was looking like, the transfer function was a function of S. Obviously, if you'll have a transfer function, it was a function of S. The different transfer function had the different functions of S. Now may I know how will we design the transfer function? The transfer function would be designed electrically with the help of electrical elements like inductor, resistor and capacitor. Yes. Let's take, you have taken the RLC and you have designed a certain transfer function. For the time being, let's take the transfer function is S divided by of S plus 1 to the power of 2. You have chosen the appropriate values of R, L and C. But one of the major and the disastrous problem is that in future, the value of R, L and C are heavily depending over the environments. That means as the temperature changes, definitely the value of R, L and C is supposed to change. And if the value of R, L, C is supposed to change, definitely even the complete transfer function which you have designed with the help of R, L and C, they would change its value. That means although with the help of R, L and C you could design this transfer function, but the actual transfer function would be something else in compare with this. Not only that, even the transfer function would change its behavior with respect to the temperature. One of the worst thing about the transfer function, it uses the hardware components. Yes, it uses the hardware component, and the accuracy would be a big problem. But once you will come under SSA, you will get to know the complete transfer function changed into form of mathematical matrix. And the mathematical matrix would have the real number within it. Like you will have the three different matrix. You would have a system matrix, you would have an input matrix, you would have the output matrix, you would have feed forward matrix. and the element within the A, B, C, D are gonna be just real values. And may I know what does it mean of it? That means the complete hardware system became a simple mathematical matrix, and now this mathematical matrix can be fed inside the computer system, and now whatever the signal was getting processed with this transfer function can be easily processed with this A, B, C, D matrix with the help of computer system. And one of the best thing regarding the computer system, you need not to go into the market to purchase R, L and C, and even once you have purchased, they would change their value depending on the temperature. But if you talk about the real coefficient within the ABCD, they would not change their value because they are just programmed within the computer system. What does it mean of it? What does it mean of it? That means the complete control system have become a software program. Software program, agreed. That is why you must be able to see whenever you refer any standard book, you will get to know towards the last side probably 15 to 20 pages are just dedicated towards the MATLAB programming. Why? Because the complete transfer function can be changed into form of program. That means in future, what is a PID controller? Is the program. What is a transfer function? It's a program. Any of the transfer function, any of the PID, any of the compensator can be just made in terms of program. The analog signal comes to that computer system anyways. Before coming to the computer system, it has to get converted into digital form. Definitely ADC has to be used. Now that ADC would get processed with this ABCD and add towards output side. And towards output side, what is going to happen? This process has been held and now it is getting forced towards output side. Towards the output side. That is what I am saying. There is no hardware at all. Now, anyways, I need not to go into the great detail of the control system. Now the PID controller which we used to have within the iron, which we use for pressing our cloths. What is a PID controller? PID controller is just a processor where we used to have a program of PID. There is no inductor, no capacitor, no resistor. What a great achievement it is. What a great achievement it is. Agreed? Probably each one of you would have a good amount of understanding what I wanted to communicate. So second and very important thing, the complete hardware system got changed in the form of programs, and in future all of the transfer functions can be just made in terms of programs. Yes. Now the next important thing, try to understand what is it. The next important thing what we are discussing over here, if you will compare again the transfer function and the SSA, whenever we have the multiple input and the multiple output, the analysis with the help of transfer function becomes very difficult. Why, sir? What does it mean by the transfer function? The transfer function is a ratio between output to the input, taking all of the initial conditions aside. Anyways, keep aside initial conditions for the time being. It's just an ratio between one output and one input. And as I was starting the control system, it was very well communicated. What it was? Most of the practical system used to be MIMO system, multiple input, multiple output system. That means whenever we come across the situation, we need to deal or we need to analyze the MIMO system, the analysis with the help of transfer function becomes very difficult. I am not saying it is not at all possible, but the analysis becomes very difficult. Anyways, we can write the next important point. MIMO system handling is easy. Obviously, I am talking in terms of yes. Till this point, I would request to each one of you, tomorrow, the Dande sir have got the marathon. I would request to each one of you, I had to get at least 5,000 number of student live. More than at least 2,000 number of student, and each one of you please do like that session, because you know the Dande sir is the best mentor in engineering field. Not only that, he is the best teacher in the control system. That is what I am saying. Each one of us who have been following me, and each of us who have been following the GATE Academy, and even your friends should attain the same thing. Agreed what I am saying? Anyways, come back. So here it becomes MIMO system handling is easy. Agreed? Yes. Till this point, nobody should have any doubt as such. Yes. Till this point, nobody should have any doubt as such. So may I know what we have studied so far? Before introducing the basic concept of SSA, I was just having a brief comparison between the SSA and the analysis or as the transfer function approach which we have been using so far. There is a big difference between the transfer function approach as well as SSA analysis. What are they? Here I would be using the transfer function, but here I would be using just matrix. There I would be designing that system using the external hardware, but here I would be designing the system with the help of a computer system. There the analysis as well as accuracy is a big problem, but here the analysis as well as the accuracy is very least problem. No, Devraj Madan, no, it won't be the last class for the control system, because probably 2 more class is required at least to cover the control system. Because the concept of the SSA, the numerical based on the SSA, I had to take into the great detail, and once this part is getting over, we would be discussing about a bit about compensators. So no, it's not the last class. It's not the last class. Yes. So till this point, each and everything is clear. Till this point, each and everything is clear. If the theoretical background of the state space analysis is known to me, I would straight away jump into the detailed analysis of SSA. Yes, tell me. If it is clear, just write clear over the chat box, and then we'll go into the detailed analysis of SSA. So let me go ahead and now put it the heading as state space analysis. State space analysis. State space analysis. Yes. Let me take a block diagram for the better understanding. In case of state space model, what are the inputs you will be having? What are the outputs you would be having? See, you would be having the physical inputs. For the time being, the physical inputs are being referred by u, small u. Let's take m number of physical inputs you have. Let's take u1, u2, u3, u4, goes till um. Yes. And let's take the n number of physical outputs you have. Let's take the output is being referred by C, maybe 1, 2, yes, or you can write with the help of Y also, Y of 1, 2, 3, n, yes. But so far in case of transfer function, I was not considering the initial conditions, but now the initial conditions would be introduced in terms of their state variables. The state variables are being referred by small x. Let's take for the time being j number of state variables you have. Agreed? Till this point, nobody should have any doubt as such. It is a type of MIMO system, multiple input, multiple output system. Multiple input, multiple output system. These are the physical inputs. These are the physical outputs. These are the state variables. These are the state variables. Yes. May I know how will we decide the number of state variable the given transfer function or the given differential equation is containing? So keep in mind the number of state variables is equals to number of effective energy storing element why the word effective is being used. In future, if you would be connecting two inductors in series, both would contain the same current IL. In that case, the effective inductance value would be only 1. Anyways, keep aside for the time being. Once I would be going into the great detail, I would understand what does it mean by the effective. Word is effective. Anyways, the number of effective energy storing element. If you have the two effective energy storing element, let's take one is capacitor, one is inductor. Keep in mind the two number of state variables you'll have. Similarly, if you have three number of effective energy storing element, in that case the three number of state variable you had to have in your given problem. Secondly, order of the differential equation. Order of the differential equation. And anyways, what does that mean by the order of the differential equation? See, if the order of the differential equation is the third order, so once you will draw the characteristic equation for the third order system, you will get to know how many number of roots you will have for that characteristic equation, 3. And may I know what does that mean by the roots of the characteristic equation? They are nothing but the number of closed loop poles. So you can see, or you can write one more important thing, the order of the differential equation, which is very same as number of closed loop poles, number of closed loop poles, number of closed loop poles. Agree? Not exactly, but yes, we can write the number of time constant. Number of time constant. Number of time constant. Yes. So anyways, once you would be dealing with any practical problem, the physical inputs would be known to you, physical outputs would be known to you, but the number of state variables which has to be taken to address the given problem in SSA technology, that would be calculated by you. That solely depends on this many factors. Agreed? So what I am going to do over here, first let me focus over the input and let me focus over the output. How will we know the number of inputs? Let's take an example. I have taken a series RLC circuit. Yes. Let's take the input DC voltage V is exciting this series RLC circuit. Let's take this resistance is R, this is L, this is C. And I need to focus over the two outputs, maybe the output voltage across the capacitance and maybe output voltage across the inductance. What does it mean of it, my dear friends? See, I had to connect this practical circuit with this MIMO system. How many physical inputs you had? You can see very well, only one energy source we had, which is exciting the complete source. What does it mean of it? That means in future, at least for this problem, the value of M is 1. Agreed? Till this point, nobody should have any doubt as such. Now, if we'll talk about the number of outputs, there are several number of outputs we can observe. The output across the capacitor, output across the inductor, output across the resistance, output across the resistance as well as inductance, maybe the current across the resistance, inductance or capacitance. But this is solely depends what are the different parameters you really wants to observe. You can see very well, I am interested in observing the voltage across the capacitance as well as the voltage across the inductance. So how many output is there? The 2 number of output is there. That means the value of N is 2. Many of the times I have seen the student, they are not very well acquainted how the number of input and number of output has to be calculated. That's not very tough task, my dear friends. That solely depends what are the different electrical parameter, and for the time being, what are the different parameters you are interested in observation. If you are just focusing over the V0, the number of output would be 1. If you are focusing across the voltage V0, maybe VL and at last VR, the 3 number of output you would have. Agreed? Till this point, nobody should have any doubt as such. Now here, the number of state variables, that solely depends on the order of the system. You can see very well, once you will calculate the impedance of the given circuit, the order of the given impedance or the order of the impedance of this given circuit is going to be 2. You can see very well, R plus of Ls plus of 1 upon Cs is equals to 0. Once I will take S as LCM, the L and C and S would get multiplied. The degree of the given algebraic equation is S square. That means the number of poles are 2. What does that mean of it? Once I would be taking this question for the reference, definitely the number of state variable which I had to take, it's nothing but 2. It's nothing but 2. Yes. Till this point, nobody should have any doubt as such. Let me go ahead into the next page. What I am going to do over here, for the sake of simplicity, I have simplified the number of inputs, number of outputs, as well as number of state variable. I have confined my number of inputs to 2. Let's take the 2 number of inputs we have. The first input is being marked as a U1, U2. Let's take the number of state variable are 2, and even I have taken the 2 number of outputs. 2 number of outputs. It's just for the sake of simplification. But yes, arbitrarily you can have the m number of input, n number of input, and similarly k number of these state variables. K number of these state variables. So now, if I would like to relate the output, how the output would get affected? The output would get affected from U1 as well as U2, and similarly its state variables as input x1 and x2. So you can write somewhere the y1 would get affected from U1. Let's take the factor of affection is going to be a11. Similarly with U2, factor of affection is U2. Similarly here goes x1, let's take is b11. Yes. Similarly, just a minute. You can write this as x1 dot. Similarly, x2 dot is equals to of b11 plus of here it's a12, and here it becomes a21 of u1. Similarly, a22 of u2, b21 of x1, b22 of x2. Agreed? Till this point, nobody should have any doubt as such. Anyways, what it is, it's nothing but it's called state equation. What it is, state equation. Why it is required? Once we will be discussing about the differential equation, and the student who have gone through my differential equation class over the mathematics, they would be able to correlate what was the actual crux of this. What was the actual crux of this? What it is called? It's called state equation. That means I wanted to know how the derivative of the state variables are getting affected from the input and as well as the state variables itself. It's called state equation. And similarly, now I would be watching how the output is getting affected. So that is going to be y1 is equals to b11 similarly x1 plus of b12 x2 plus of c11 u1, c12 u2, and similarly y2 is equals to of b21 x1, b22 x2 plus of c21 u1 plus of c22 u2, yes, c22 u2, yes. Only one difference has been taken. X1 has to be replaced with the U1, U2 has to be replaced with the X2, U1 has to be replaced with the X1, and similarly U2 has to be replaced with the X2. So you can see very well what is the X1 dot. X1 dot is nothing but the A11 X1 plus of A12 X2 plus of B11 U1 plus of B12 U2, and similarly X2 dot is equals to of A21 of X1 plus of A22 of X2 plus of B21 of U1 plus of B22 of U2. Similarly, the Y1 is equals to of B11 X1 plus of B12 X2 plus of C11 U1 plus of C12 U2, and similarly Y2 is this. Agreed? Till this point, nobody should have any doubt as such. It's called output equation. What it's called? It's called output equation. You can see very well why it's called output equation, because the output variables Y1 and Y2 are getting connected with all possible inputs. The 2 number of physical inputs as well as 2 number of input which have come in a form of state variables, in terms of state variables. Agreed? Till this point, nobody should have any doubt as such. So end of the day, what I am going to do, that is very, very important, keep in mind. Now can't I write this complete state equation in a form of matrix? Yes. That is why even the data has been chosen in such a way that in future A11, A12, A21, A22, they would become a coefficient of a given matrix, So what I am going to do over here, see, try to understand in this way. Can I write like A11, A12, A21, A22 of x1, x2 plus of I can write somewhere here, B11, B12, B21, B22, which is getting multiplied with U1, U2. U1, U2. Yes, the first equation can be easily written in this linear format. And similarly the second equation. So end of the day, rather writing each and everything in the great detail, let me ask one thing. The both of the equations can be written in the standard form of x dot is equals to of a of x plus of b of u and similarly output y can be written as c of x plus of d of u. Nobody should have any doubt as such. The first one is called state equations or the matrix which is retrieved from the state equations. The second one is called output equations. Yes. Matrix A is called system matrix. Matrix B is called input matrix. Matrix C is called output matrix. Matrix D is called feed forward matrix. Similarly, matrix X is called state matrix, because you can see it contains the state variables. Similarly, U is called the input matrix and similarly Y is called output matrix. Such a good idea you should have. Agreed? Nobody should have any doubt as such. Agreed? Till this point, nobody should have any doubt as such. Now, I would like to ask one of the very, very important fact. If you have a MIMO system which has to be analyzed using state space analysis, let's take 4 number of input you have. Starts from U1, goes till U4. 3 number of outputs you have. Y1 goes till Y3. And let's take the 2 number of state variables you have. For the time being, let's take it's the x1 and x2. May I know what would be the order of A, B, C, D, system, input, output and feed forward matrix? This is the point where many of us used to trap ourselves. May I know what would be the order of the matrix A, B, C and D? Anyways, straight away jump into the order of A, B, C and D. I should have a clear cut idea about the order of x dot, y, then x and then u. So we'll have even better idea. So, yes. Tell me what would be the order of x dot? One thing is quite self-explanatory. It would always be a column matrix. Then only in future it would make a linear simultaneous equation. It would be a column matrix. That means the order is gonna be m cross 1 and here also maybe m cross 1. Agreed? What does that mean? How many number of x dot you would have? That solely depends on the number of state variables you have. How many number of state variable you have? Only it's a 2 cross 1. 2 cross 1. Agreed what I'm saying? Agreed what I'm saying? And similarly, if you talk about the order of y, again it has to be a column matrix. It has to be a cross 1. How many number of outputs you have? The 3 number of outputs you have. So it's simply going to be 3 cross 1. 3 cross 1. Agreed? Nobody should have any doubt as such. And if the order of x dot is known as 2 cross 1, so definitely it would also be it's a column matrix, it's a column matrix. It would be 2 cross 1, it would be 2 cross 1. Agreed? No doubt as such. If you talk about u, again it would be a column matrix. Why it would be a column matrix? See, end of the day, it has to be a column matrix, then only the column matrix plus column matrix would make a column matrix. May I know how many number of rows it should have? You can see very well. So you can see very well, it has to have only one column, so only cross 1 you would come, cross 1 would come. How many number of input you have? The 4 number of input you have, that's a 4 cross 1 and that's the 4 cross 1. That's a 4 cross 1, agreed? Till this point nobody should have any doubt. Now tell me what would be the order of B, D, C and A? B, D, C and A. Tell me what would be the order of B, D, C and A? Now each one of you would have a clear cut idea what would be the order of A, B, C, D. See, the resultant of AX has to be 2 cross 1, then only it can be equated. See, the addition of this plus this matrix has to be this. The addition between this and this is possible only if they have the same order, and even they would have the value as 2 cross 1 if the multiplication of AX itself is a 2 cross 1. By default, the A has to be 2 cross 2. A has to be 2 cross 2. Similarly, if we talk about B, may I know what it would be? It has to be 2 cross 4. It has to be 2 cross 4. Agreed? Similarly, if we talk about C, the resultant has to be 3 cross 1. How it's possible? It's possible only if it is 3 cross 2. If it is 3 cross 2. The resultant has to be 3 cross 1. When it's possible only if it is 3 cross 4. 3 cross 4. 3 cross 4. Agreed? Nobody should have any doubt as such. Nobody should have any doubt as such. So may I know what would be the order of A? What would be the order of A? What would be the order of B? What would be the order of C? And what would be the order of D? For the better generalization, what I have done, I have taken the m number of input you have, n number of output you have, and let's take the k number of state variables you have. So I want the input from each one of you from the live chat. Tell me what would be the order of A, obviously in terms of m, n and k, order of B, order of C, order of D. Once you have thorough with the order of the system, I am going to take electrical system which have come in GATE electronics year of 2020, where the electrical system has to get converted into its equivalent form of SSA. SSA. Tell me what would be the order? What would be the order about A? You can see very well. Here it is gonna be 2 cross 1. In future it would become m cross 1. And even the x and x dot would have the same order, it would also be a m cross 1. Yes, here it is a m cross 1, here, here it is k cross 1, here also it's a k cross 1, so A has to be k cross k, k cross k. So if we talk about order of matrix A, it would be k cross k, it would be k cross k. Till this point nobody should have any doubt as such. Anyways, I want to get the order of B, C as well as D in terms of M, N, N, K. M, N, N, K. Tell me what would be the order of B? What would be the order of B? See, U would be equals to, try to understand in this way, U would be equals to where it is M cross 1. U would be M cross 1. Being a column matrix, definitely first the multiplication of B and U is taking place. That means the number of column with B should match with the number of rows of U. So the B would have cross of M. There is no doubt in it. Cross of M. Now how many number of rows we should have with the BU? That's solely defined by the number of state variables we have. How many number of state variables we have? That's nothing but K. So definitely it's gonna be K cross M. K cross M. Agreed? If we talk about C, C is again gonna be an output matrix. What's gonna be the order of it? So you can focus over here. First focus over the Y. Y is gonna be a column matrix. It is the worth of 3 cross 1, or in general we can write this as N cross 1. N cross 1. Agreed? So by default, the number of rows which C should have, it's n. There is no doubt in. There is no doubt in. Because once the multiplication between the C and X would take place, the number of column would be decided by X and the number of rows would be decided by C. See? Now you can see very well this and this has to match. What it is? It's a nothing but the number of state variable. Here also the number of state variables has to be very same. Then only their multiplication is possible. How many number of state variable we have? K number of state variable we have. K number of state variable we have. Yes. And one thing is quite sure. Even they may ask a question, maybe probably for the 2 marks they would just be giving this, and they may ask what would be the order of A, B, C and D. I know many of us would get trapped over this problem itself. D, I want the answer from each one of you. At least for the D, I would be expecting that you guys would be giving the proper answer for the D. You guys would be giving the proper answer for the D. Tell me what would be the best most answer. What would be the best most answer? D. I want the input from each one of you. Probably 2 more classes are left out. 2 more classes are left out. Anyways, I want to get the exact answer of D. Exact answer of the D. Again, the same concept goes of Y. Y is gonna be how much? N cross 1. N cross 1. That means the number of rows the D would have, it's simply N. Simply N. And now the multiplication between D and U is possible only and only the number of column with D and the number of rows with U should match. How many number of rows the U would have? The number of rows is simply equals to of M. So simply it's gonna be N cross of M. N cross of M. Such a well-designed problem can be plotted in future. Such a well-designed problem can be plotted with in future. Yes. Yes. Now, let me go ahead with a question which would be the homework to all of us. The first question may be yes. I need to convert this system into its equivalent SSA, state space analysis. That means I need to get its matrix A, matrix B, matrix C and matrix T. And here one thing is quite clear, the input has been precisely taken as V in and the output variable is only one, that's nothing but the V naught. I need to get the value of ABCD. ABCD, yes. Agreed? Once this part is over, I may take another problem. The problem is like maybe V naught, sorry, V naught it is. V naught it is. Again, I need to get the value of A, B, C, D. Yes, A, B, C, D. So you had to try this problem with yourself. Definitely, you would not be able to solve properly, but in tomorrow's class, definitely we would start with this problem itself. We would start from this problem itself. But I would like to ask one thing. What would be the order of A, B, C and D at least in this problem? The order of A is gonna be the number of state variable cross of number of state variable. It is in order of 2 system, definitely it's gonna be 2 cross 2. That is how you can calculate the order of B. That is how you can calculate the order of C. That is how you can calculate the order of D. Order of A, B, C and D. Order of A, B, C and D. Agreed? Agreed what I am saying? Nobody should have any doubt as such. Nobody should have any doubt as such. Agreed? Now I would request from each one of you, the guys who are having any specific type of doubt, you can post over the Telegram. So end of the day, what I am going to do, if I find any of the problem which are well designed problem or had a certain quality, definitely I would be discussing over my video itself. Over my video itself. So you guys would not have any doubt or any problem as such. Agreed what I am saying? So anyways, for today's, it's more than adequate. We'll meet tomorrow with the same concept and same enthusiasm. Okay then, we'll meet tomorrow. Thank you. Thanks a lot.